we should get started. Welcome, everybody, to Build a Microsoft Graph-powered web and mobile productivity app using Teams, Outlook, and SharePoint. That was quite a mouthful. There are trade-offs to letting committees design session titles. But on the upside, we've got an absolute ton of action-packed demos and interesting discussions about things that you need to know when building these kind of applications. So my name is Darrell Miller, and I am the Chief Slide Engineer, and with me is the Maestro of Demos, Jason Johnston. Hello. And before we get started with our demos, because we want to get right into it, we have a couple of obligatory slides to show you about what is the graph. And for those of you who are already intimately familiar with the graph, please just take the time to revel in the beauty of these professionally done slides. I can take absolutely zero credit for them. So the Microsoft Graph, it's all about providing access to your data and the data of your organization. But we don't want to just give out that access to that information to anybody. We need to be able to access that information securely and in an industry standard way. So we are built on top of the Microsoft Identity Platform. A Microsoft Graph contains information from Office 365, Windows 10, Enterprise Mobility and Security, and you can access this information using the Microsoft Graph HTTP API. And with that, you can build all kinds of experiences: web apps, bots and agents, device applications, native applications, daemon apps, workflow automation. The world is your oyster. You can even extend existing Microsoft 365 experiences. And with our announcement at Build of Microsoft Graph Data Connect going GA, there's a whole new range of insight applications to give insights into your data that is stored in the Microsoft Graph. And there's more. Coming soon, we will have graph connectors, which will allow you to bring your data into the Microsoft Graph and be able to search on that data alongside all the other data that is already there. Now, Microsoft Graph-based applications are made possible because of a wide range of data and services. In this session, we're going to be demonstrating and discussing applications that use a subset of those capabilities. So we're going to talk about auth flows like auth code, implicit grant, on behalf of, client credentials, UX elements like web components, React components, a whole bunch of different stuff. But this isn't everybody. This isn't everything. But we are only one of 4 sessions. We're the first session talking about rich interactive experiences, but tomorrow there'll be a session on bots and agents, background processes and automation, and insight apps. Now, all of these sessions were all based around this mythical Contoso Airlines. If you were in the overview session, who were in the overview session? Who came to see this session because you saw it advertised in the overview session? Yeah, that's good. Things are working as planned. Excellent. So, Contoso Airlines, a small airline, 95% domestic, 4,500 flight crew, you know, the medium-sized kind of business, 60 developers, and they are Office 365 E5 subscribers. So let's talk about the scenarios that we're going to be covering in this particular session. We're going to talk about mobile device applications. We're going to talk about web and desktop rich applications, and also integrated experiences. For each of the scenarios, we're going to introduce a scenario, kind of describe what makes it unique, and then we're going to have Jason demo an application that demos this particular scenario, and then we're going to discuss some of the design choices that we had to make in coming up with the application, and potentially other issues that you might run into building a similar kind of application. So let's get the show on the road and introduce our first scenario, mobile device applications. Mobile device applications are about reaching employees in the field. It's about putting information at their fingertips so that they can be more productive, more effective, and happier employees. But there are issues to consider when building mobile applications, one of them being reliability. You're often on low bandwidth networks, you may be on metered networks, you may have really connected to a network with poor reliability. You may, if you happen to be in a plane at 35,000 feet, have no connectivity whatsoever. And so one way to address no connectivity is having offline data. So this is something we need to consider. But once we have offline data, we've got our user data that's on a device. Some employee could lose that. We need to be able to secure that data. And luckily, the Microsoft Graph has some nice capabilities for managing devices. And if you go back to the overview session at Ignite, Jeremy and Nina did a demo showing how to reset phones if they've been lost via the Microsoft Graph. So chances are your employees will probably want to use their own device in order to be able to access their data, rather than having some kind of company-provided device. So having one platform is not enough. You're probably going to have to support Android, iOS, and there may be some die-hard Windows Phone fans out there. I love my Windows Phone. So retrieving information onto the phone is only really one mode of communication. It's useful, but it's also really important to be able to update those field employees using notifications, to be able to take some event, some data that changed in the cloud, and push it down to them so that they are notified of it immediately. So all these kind of things we want to take into account, but enough talking for me. Let's hand it over to Jason to demo some of his goodness.
All right. Yeah, if you don't mind. Actually, number 7.
Number 7.
Yeah. Okay, so thank you.
Right? I pressed it way too many times. It's going, it's gone. We're good.
Are we still good? Yeah, we're good. Okay, great. So the application I'm going to demo for you guys is just called Flight Schedule. It's a simple little app intended for flight crew to have on their phones. The basic usage of it is to give them sort of an at-a-glance view of their flight schedule. So let's just open that up. So here we see Alex is using this application, and he's logged in. His very next flight is right up front in a card, and he's got, the at-a-glance pic of the rest of the crew. This is all coming from Microsoft Graph, of course. And then other flights, later flights are down in the list below. So the data from Graph here is coming from a few different sources. So we're calling user-centric APIs to get Alex's photos and the rest of his crew's photos. But we're getting the information about his scheduled flights from his calendar. So we're actually just making calendar calls to get that information and build that UI. Now Alex can go in and tap any of these flights and bring up a detailed view, which has a little more information about the flight and gives us contact options for the rest of his crew members. So very quickly he can just pop in here and decide he wants to send a text or give them a call. You also notice up at the top here that we've got information departs from gate C32. That information is actually coming from an open extension that's stored on the event. So we're actually extending the base event to add app-specific data there. Okay, so let's switch over and take a look at the code that is making some of this stuff happen. Thank you, Daryl. Actually, one last thing that I did want to show you, and Daryl mentioned it, the notification piece. So the app itself is fairly basic, fairly straightforward, but the real reason that you want your employees to have this is for notifications. We all know that sometimes things happen, and very short notice, flight gets moved to a different gate, or the departure time gets pushed back because of delays. So the big feature of the app is being able to notify that flight crew as they're walking through an airport that they actually need to turn around and go to a different terminal altogether. So the way that happens is this is sort of the source of truth for all the flights that are flight administrators uploading flight plans and setting fields in this SharePoint list about the flights. So if I come in here and find a flight that Alex is assigned to. Okay, here's one. let's just say I'm going to change the departure gate to A4. What happens when I update that SharePoint list is that kicks off a background process that's triggered through a webhook, and it's doing all the necessary things to go and update events in the crew's calendars, update things for the flight, but it's also using the Microsoft Graph to send notifications to these users using Graph notifications. And if we, I guess we missed it, but you can see it's just a native iOS notification that comes up and very quickly lets them know that this flight has been updated with a new departure gate. Okay, now we'll go and look at the code that drives these scenarios. So thinking back to some of the things that Daryl talked about with the considerations that we need for a mobile application, the first thing that I wanted to show you was how we manage user photos. So there are a couple ways that we sort of try to be smart about this. First is that we cache user photos. I mean, user photos don't change that often, and there's not really a need to fetch them every time we load the view. So we do cache those. And so the first thing that we do when we're getting a list of users' photos is we check against our cache and just use any cached ones. Any users that aren't currently in the cache, we add them to this list of users to go fetch. The second thing that we do to try to be smart about this is we actually use a batch request to get the user's photos. So instead of making one individual request to download photo by photo by photo, we package that all up into a batch, ask for them all at once, and then bring them down that way. Okay. And then the other piece that I did want to kind of show you is how we get that calendar data from the user's calendar to build the flight list. And again, with keeping in mind that we're on mobile and we want to try to be as efficient as possible, we're doing a number of things to keep the size of our packets down. So the first thing that we're doing is we're actually making an API call to calendar view. And that has a few standard parameters that we need to pass, a start and end date time, which gives us sort of that window of the user's calendar that we want to retrieve. Then we start doing some things to modify the response. The first being select. Using the select statement, we're basically saying we only want these fields back. As you can imagine, or if you've looked at it, an event object in the graph has quite a few fields. And some of them can get a little large, like bodies and things like that. Our app doesn't care about that, so it just makes sense to exclude them all and just get the data back that we want. So we're already starting to cut down on the size of the response. The second thing what we do is we use a filter. And for this particular application, the flights or the events that we care about always have a category assigned to them of assigned flights. So we're using a filter to say, only give me back events that have the assigned flight category. Next, we're actually increasing the size of the response slightly by using this expand query parameter. And what we're doing here is we're asking for the request to include the open extension that I mentioned earlier. It's going to have some flight data, and the reason that we do this here is that saves us from having to go back and make individual calls for each one of the events to separately retrieve the open extension. And then finally, we are calling this order by. That just sorts them sequentially, and it saves us from having to do it in the app. So, and with that.
And the one thing I missed when I first saw the sample is like, wait, that's not C# code? That's Swift code.
It is Swift code, yes. This is a native iOS app. I don't want to give the wrong impression. It wasn't written in VS Code. I'm just using VS Code to display it. But yes, it's Swift, It's
And
using your
our
Microsoft Graph SDK and
Objective-C one that we
providers.
just GA'd here at Build.
Yes, it is. Yes, it is.
Excellent. Well, thank you very much. Yep. Wasn't that pretty? It reminded me of a Windows Phone app. So, he just makes it look easy, right? But the reality of it, there are many engineering decisions that need to be made when building this kind of application. And with every decision, there are trade-offs. So let's talk about some of those things. One very common question that comes up when talking about building mobile apps is, should we just call the graph directly, right? Like, should we just hit the graph directly, or should we call our own API and then call the graph afterwards? Because that's the other way you can do it. And there are pros and cons. If you call the graph directly, you get to rely on graph scale. We have thousands of nodes. We have nodes distributed throughout the world. You don't ever have to worry about having to scale up the graph or provision another graph. It's already done for you. But there are limitations. You only get delegated access. So that means that your application can only access data that your user is actually allowed to access. If you introduce an API layer, then it becomes on you to support scale. You have to provision in the appropriate regions, the appropriate amount of servers, and that may not be a problem for you, but you get the benefits of you don't have to, you can now use app-only mode so that your application can access information that your users can't necessarily. And in Jason's app, he mentioned that the data was stored in a SharePoint list, and that's where all of the source of truth was, but the user does not have direct access to that. So it's important for app-only to be able to achieve that. You get other benefits by having the API. You get to do transformations of the data. You can do resource composition. It also gives you a place to trigger notifications if you want to send out notifications. Now, at the moment, notifications would go out with what we call on behalf of flow to ensure that the user has actually granted permission to receive notifications, but there are app-only notifications that are coming soon also. So there's trade-offs. Another common scenario is retrieving a set of data and then refreshing that data periodically. Ideally, you don't want to just retrieve all that data all over again. You want to just get the changes. And that's what data sets are designed, Delta queries are designed to do. That's their main purpose. But, and the way Delta query works is you make a request saying, I want to do a Delta sync on this particular chunk of data. So you make a special a Delta request, and you get back a Delta link. And then in the future, you make additional Delta link calls, and you only get back the changed data. But there are limitations to Delta queries, and those limitations do depend on the particular resources that you are trying to access. And luckily, those dependencies and limitations are well documented within the docs. In Jason's demo, he mentioned that he was creating a window of events. It was a period of 30 days. The problem is that 30 days changes every day. Right? So a Delta token would only be good for one day because the window changes the next day. Also, you notice he used expand to expand and pull additional open type extensions. Well, you can't use expand at the moment with Delta queries. So in this case, filtered polling was important, and it was important to be able to limit the size of data that was coming back, limit the rows of data that were coming back, so enable to do polling. And sometimes what on the surface appears to be the right choice may not be. Unfortunately, this is still an engineering profession where we have to do measurement and check and test various scenarios and see what works best for our particular case. So you've got two different options there in keeping data up to date. This is a controversial topic, and one very close to my heart as I am the PM on the Graph SDKs. Some people just don't want to use an SDK. They're like, no, I know how to make HTTP calls, it's fine. I don't want to have to go off and learn your new library. And We completely hear that, and we've been trying to build more flexibility into the SDKs in order to give people different options and just be able to use the parts of the SDKs that they want. And now there's nothing that stops you from doing this yourself, but if you really just don't want to use an SDK, I'd love to hear about all of the reasons why. Now, for some people who like to use SDKs, we're doing all kinds of work. We mentioned we did the GA of Objective-C. We now have Java SDK supports Android. We're doing more support. We now have multiple languages that we provide beta SDKs also, so that you can play around with the new stuff coming using the SDKs, and we're trying to get those out and updated as often as possible. Some people, however, are concerned about the full SDK, and they say, yeah, but it's just too big. And especially if you're building mobile applications, you can be sensitive to the size of SDKs. And now we have more options. We have what we call our core SDK. So the SDK is kind of split into two pieces, the core and the service library. The service library contains all the generated code and request builders to be able to cover the entire app. The core contains those cross-cutting concerns, that help that we can provide you in doing authentication, help in dealing with rate limiting and automatically dealing with throttling responses like 429 and 503. And things like secure redirects so you don't leak tokens. And we are building more and more of these pieces of middleware in order to be able to do response compression and stuff like that. And those live in the core SDK, which is much more lightweight. So it's now, we have an option. It's not an all or nothing proposition. Maybe the core library is what will work for you. It's also worth noting that there are some specialized SDKs from different teams. The notifications team have an SDK, and the calling team for doing video calling have some SDKs that are complementary to the Graph SDK. When you have no connectivity, it becomes very useful to you to have some data stored on the device, so the app is still valuable to the user when they are at 30,000 feet. And there's a few ways that you can approach this problem. The classic is kind of replication, a delta sync, and you can use delta queries to enable this so that you can just make sure changes that happen on the client are replicated to the server and vice versa. And this works with a fairly simple data model. When you start to get a more complex data model that has interdependencies between the data, it starts to get more difficult in order to maintain this kind of simple syncing mechanism. Another approach is what we call app caching. And this is what effectively Jason did with the profile photos. He built the code that took the profile photo, identified it with some kind of identifier, put it in some local storage, and then when the code is going to retrieve that profile photo, he went and goes, okay, which one is it? Do I already have it? Yes, I do, therefore I don't need to make the network request. Which is cool, but it's a whole bunch of code that you have to write for that particular scenario. I mentioned the notifications SDK. They also have app caching built in order to give you a history of the notifications that you received. They also do a little bit of syncing also so that when you acknowledge a notification on one device, you don't have 7 other devices going, oh, by the way, did you hear that? Oh, by the way, right? So by doing that little bit of syncing with the cache data, they're able to build a better user experience. So the thing is, while you have to keep doing this generic, resource-specific code to do the caching, it's a lot of extra work. And it's not a new problem, right? We're making HTTP calls. There are standardized HTTP caching protocols and methods and libraries out there where you can basically use a URL as the identifier for the resource, and there are special headers that the server returns that tells you how long this content is good for, and you can then get to do clever things like say, well, I have a copy, but it's currently out of date. Could you tell me if you have a newer copy, please send it me, otherwise just return that 304 not modified, and then I'll use the local copy. When you're working on a metered network, like a mobile device, bytes cost money. And we are looking at how to integrate these kind of HTTP caching libraries into our SDKs to get this value automatically for you. Concurrent data access. Jason mentioned about being able to batch requests when he retrieved down the list of information about the crew. Rather than making multiple different requests to the server, made one request to the server. And sometimes this is really a useful pattern to minimize the amount of network traffic that creates, right? So, and we've built classes into the SDKs to make it even easier to make these batch requests. The batches, however, are not necessarily the fastest way to get all that data. It depends on the particular request that you make. Because let's say you have several requests that you're making, and some of them are very quick, but some of them's longer. One of them's a longer one to do. You have to wait for all the requests to complete and all the responses to be ready before the complete batch payload is returned back to you. So it's actually sometimes more efficient to do parallel requests, where you send off multiple at the same time, and then as soon as one gets back the data, you can start processing that immediately. And we have an example later on where Jason actually uses that because he's got a nice programming model. One of our challenges, especially in some of the strongly typed languages, is the programming model for making these multiple parallel requests isn't very pretty. But we're working on making that easier too. So that brings us to our next demo. I mean, there's probably a ton of other design questions that we could go through, but we have more demos, so let's see more demos.
All right, cool.
The next, I have the scenario to describe first. So this demo is about providing rich interactive experiences to your team, right? This is about how do you access the data that's not my data, it's somebody else's data. And in this case, it's the flight manager. The flight manager wants to access the information about the crew and their existing reservations and existing flights. And the thing that's important here is that in order to do that, they need to belong to a particular security group in order to access that data. This demo, it doesn't need a whole lot more introduction. It does a great job of speaking for itself, so I will let Jason take it away.
Oh, okay.
6, right?
Yeah.
Nice. I'm learning.
6 is right. Okay, so this is the Contoso Flight Schedule Manager, and this is sort of the next evolution of the mobile application. This will give us a little more control over those schedules. So, as Daryl mentioned, the flight admins can use this to assign flight attendants to flight crews, but the flight attendants themselves can also use this application to go in and see which flight crews have open spots on them and go ahead and sign up for those if they want to. So I'm going to show you both, but we're going to start with the flight administrator experience. And I just want to point out, you may have seen the Microsoft Graph Toolkit in some of the keynotes. This app is also using the Microsoft Graph Toolkit. Right now, we just see the sign-in control from the Graph Toolkit, which is a nice experience for us. What's nice about it is I didn't have to write any code to make that work. And you see that the control updates to show the logged on user after I'm logged in, and we have this nice little flyout card if I wanted to come in and sign out. Okay, so here we are in the flight admin view, and it needs a little explanation, I think. Do you like the colors?
Yeah.
So the idea behind these colors is that Contoso sort of has a global policy that all flights have to have at least 2 flight attendants on them, but ideally they would have 3. Okay, so the color coding sort of follows that model. If there's less than 2 and it's out of policy, the flight is going to show up as red. If there are 2 exactly, it'll show up as yellow, and if the flight has a full contingent of flight attendants at 3, it'll show up as green. So let's just pick one of these to take a look. And again, here we see some more Microsoft Graph Toolkit components across the top here. This little card is the person component from the Graph Toolkit, and these are also the person component, just in a slightly different form factor. Okay, so the idea behind this, we see that the 3 slots for the flight attendants, and we've only got 1 in this particular one. And if we scroll down here, we see a list of all the flight attendants in the company and their availability. Okay, so the green shaded box sort of gives us an idea that they need to be available in this time frame because that's how long the flight will be. So we can very quickly see which flight attendants are available. And if we just select a couple of flight attendants, then they get added up to the top there. And when I update this is going to go, and hopefully we'll see Flight 395 flip green. Yes, great. So what happened in the background there is that app went and updated the SharePoint list item that backs this flight, which then also kicks off all the background processes that add the event to their calendars, et cetera, et cetera. Okay. So now let's flip over and look at a flight attendant's experience in the same application. Okay, so now I'm signed in as Alex Wilbur. He's got this view of, and I'm actually going to refresh because 395 is still showing red for him. Okay, so 395 has actually disappeared from his available flights because it's full. It's not available to him anymore. So the view here is slightly different. We use the same color coding scheme, but he's got a list of upcoming flights that he's already assigned to at the top, and then down at the bottom, he's got a list of flights that aren't full and that he's not already assigned to. Okay, so in this particular case, we only have one available. And if he taps that flight, then we get a fly out from the side. He can see the already assigned flight attendants, so he can make that decision if there's a flight attendant that he doesn't get along with, maybe he doesn't want to sign up for this flight. But he's fine with them, so he can now just scan his calendar really quickly to see if he's got any potential conflicts. And unfortunately, on this particular one, he's got a dentist appointment right before the flight is supposed to leave, so it's probably not a good idea to sign up for this one. So he'll just cancel that out. Okay. So now let's take a look at some of the code that is driving that. And the first thing I'm showing here is one of the React components, because I want to show the Graph Toolkit component and how fairly simple it is to use. So this is the Toolkit component. This is driving the cards across the flight manager's edit flight dialog. And you can see here, all I've got to do is add the component, set this person query to a user ID, which in this case is their email. And then just using these attributes, I can control how the control renders. So by saying show name and show email, it's going to display those attributes. And that component is actually doing all the graph work to retrieve that data. So we're not having to write any code to do that specific stuff. And then I wanted to show you for Graph, the things that we're doing in Graph. This is in the back end. So in this particular case, as Daryl had mentioned, that sometimes you may have direct calls to the Graph from your app, but sometimes you may have a middle tier. We have a middle tier in this particular application. The front end is React, and the back end is ASP.NET Core. So in our Graph service class, we've got a whole bunch of utility functions that are driving different things that we need to do. And I wanted to show you the get schedules function. The reason I want to show you this one is because I think it's kind of cool. It's a fairly new API on the Graph, and it allows the user to query a whole bunch of other users and just get back a availability map, per se. And this is what's driving that list of flight attendants and their availability in that UI that we saw earlier. So just very quickly to walk you through the process, we define the start and end time, very similar to the calendar view that we saw in the mobile app. I'm getting all of the flight attendants from Azure Active Directory just by querying the group members of that flight attendant security group. And then I'm pulling out all their email addresses, because that's what I need to pass to the getSchedule method in Graph. And then just using the Microsoft Graph.net SDK. I'm making that call to get scheduled, passing the parameters. And I also wanted to point out this with user assertion. So we're adding this into the call. And what that's doing is it's actually invoking the on behalf of flow, which Daryl had mentioned. So just to give a really quick overview of the auth for this particular app, the user is signing in to the React front end and getting a token which gives them permission to call our back end. Okay? That token doesn't have any permission to call the graph itself. When they send that token to the back end, it needs to do an on behalf of flow to exchange that token for a graph token. And that's all handled for me by the Graph SDK, MSAL, and the Graph SDK auth providers that just make that happen for me. And to show you just how that gets wired up, in our constructor for the class, we are creating a couple of different client applications. The first one is this on behalf of provider .create client application. Now what this is, it's really just a helper function that generates an MSAL confidential client application for you. So all I'm doing is passing in the configuration information for my app registration, creating that MSAL client, and then I am wrapping that in an auth provider, an on behalf of provider, and then I pass that provider into the constructor for the graph service client. And that's it. I don't have to do anything to do auth. I don't have to really think about it anymore. Every time I use that client and I pass in my token that came from the React.js front end, it handles doing all of the exchanging, caching of tokens, refreshing tokens for me. So with that, back to you.
Excellent. So much of the customer feedback that we received was you need to make auth easy. Hopefully we're getting there, because we realize the challenge of doing auth, and there's so many different scenarios, and we're trying to make it so that it's more sane to be able to get those tokens and manage those tokens, along with all the work that's happening in MSAL. So I'm going to make an assumption based on the stats of registration. This is largely a dev audience, so I'm not here to lecture you about architecture of web apps and things, but I do want to call out some specific aspects of how Graph gets involved with how you choose the architecture of your app. When you're building a web app, obviously SPA is a very popular approach, and you can sort of think of a lot of the constraints around building a SPA against Graph as similar to the mobile device, because it is a public client. So you have the same challenge of delegated access is all you get. You can only access what the user themselves have access to. You also have the benefits of scalability, because we have a big cloud, Graph Cloud, out of there. The other option, of course, is you can build a browser and build a traditional web app in whatever language, ASP.NET or Java, Tomcat type application, in order to have that middle layer that then gives you the ability to do transforms and resource composition, and also be able to do the app-only scenario. The interesting thing is you're not limited to an either-or here. You can do a hybrid type scenario as well. And that's sort of what Jason did with using the React components on the front end to do the sign-in and to do some of the rendering. He's actually calling the cloud directly from the browser, but then for other pieces, calling the web app or API in order to do other capabilities that maybe need app-only type provision. So you get to have your cake and eat it. We talked a little bit about delegated access, but I want to dig in a little bit and drill down on some of the things that Jason showed there. And delegated access is fairly easy to understand. App-only is a little bit more tricky. We have a session tomorrow morning on daemons and services that will drill down a lot more deeply into app-only type stuff. As we mentioned, sometimes web apps need to do both in the case of needing to be able to access this SharePoint list on behalf of a particular user. And Jason's sample showed using 2 clients. He created one client specifically to do user requests and the other to do app-only requests. You can do it that way, but then you build up 2 HP client pipelines and you have 2 different sets of overlapping infrastructure. You can also use a mechanism on the HP client which we call the per request auth provider. So you can set up a default auth provider for the normal calls that you make, but then on a particular case, for this particular request, please use a different auth provider for that scenario. And it allows you to just use a single HTTP client. Once you've got 2 auth providers, the question often comes up is, well, I'm using both client credential stuff and I'm using either an auth code flow or an on behalf of flow. Should I have 2 different app IDs? You could create 2 different registrations, but you don't need to. And in fact, if you go into the app registration portal, it shows you app-only scopes that have been consented separately from delegated scopes. We have heard some scenarios where people have had challenges getting it working with one app ID for both scenarios, but it should work. If you do have issues, please give us feedback. Oh, I forgot my little, there's my app only. I like that little icon there. So when you're building these kind of rich client applications, I have good news and I have bad news. The good news is you have an absolute ton of options to choose from when it comes to building these apps. They can be client-side stuff, server-side stuff. It all works with Graph. We support a very wide range of platforms. So the bad news is I'm not going to help you choose which framework to use. You can use whichever you like. We do, however, recommend, this is the link to the Microsoft Graph Toolkit that Jason has been showing, and it's an open source on GitHub, as are all of our SDKs. So please take a look and use them as much as you can and contribute back if you're interested. Which brings us to our last demo, which is our integrated experiences demo. And in this case, what we're trying to do is we're trying to reach our customers where they are, right? Customers who have Office 365, Microsoft 365 subscriptions are working daily in Teams, Outlook, SharePoint. They're doing this on a day-to-day basis. Why not bring the data to them right in those experiences? And there's a bunch of ways you can do this with actionable messages and web parts and bots, and it keeps the user within their context, and it enhances their existing experience. And it's just one less login for them to do. So with that, let's go ahead and see the next demo.
All right, thank you. Yes. Okay, so for this demo, I'm going to set a little bit context. We're not the background process session, so I'm not going to go into a whole lot of detail. But when flight attendants or pilots get assigned to a particular flight crew, there's background processes that are going on that are adding them or removing them from specific teams in Microsoft Teams. In this case, again, we're logged in as Alex, and we see he's on a couple of flight crew teams in here. Part of the provisioning process when the team gets created is it's doing some things with SharePoint, creating a SharePoint page, and adding a custom web part. So this demo is actually the web part, and I wanted to just kind of give you guys a quick demo of the web part and then look at some of the code. So when that team is created, the page gets created, the web part gets added, and we add that page as a tab to the team. So if we go in here and look, this is going to load in the crew, hopefully. And give it a second. Okay.
This stuff just gets prettier and prettier.
Thanks, Daryl. You're nice to say that. So this bears a little explanation. So the idea behind this is that Contoso uses sort of a incentive program by tracking certain stats on their employees and ranking them up, if you want. So actually, we've got two different kinds of statuses that we're wanting to display in this web part. One of them is, one type is sort of a yes/no type thing, and it's used to indicate that they've either gotten certain certifications or completed certain trainings so that they're available to fulfill certain roles on the flight if need be. So for example, and I hope you guys can see that, this little medical bag next to Christy's job title lets us know that she's had first aid training. So, you know, if something bad happened, she might be able to help. The second type of badge are these sort of bronze, silver, gold medals below their job title. And these are progressive, so that there's a certain count that's being tracked, and they rank these up. So for example, Christy has the silver medal in the number of flights. And by hovering over this, she gets an idea like, I've got 122 of 200, so once I get to 200, I'll earn the gold medal of this. And this is all, again, coming from Microsoft Graph, all through the user's API. The badge data itself is, again, being stored as an open extension on the user. And we'll take a look at exactly how that works in a second. Okay, so I'm going to flip over to the code. So this web part, I created it using the SharePoint generator with Yeoman. So if you are new to web parts, as I was when I created this one, check out the Yeoman generator. It really makes things super streamlined to get started. The thing about this is when you create one with Yeoman generator, it sort of follows a standard pattern. So we have a standard sort of entry point, which is this crew badges webpart.ts file. And this is where we sort of get access to the Microsoft Graph. So right in the render method of this sort of root element, we're calling getClient off of this MS Graph client factory, which is on the SharePoint framework context. Okay? And then once we have the client, we're just passing it along to the child elements as a property. Okay? So the next element in the chain is sort of this crew badges container element. And you can see that when we hit this component and it's getting ready to mount, or it did mount, then we can make our graph calls to build out our UI. And if you've used the Microsoft Graph JavaScript SDK, this might look familiar. The client that we're getting back through the SharePoint framework is the same client that you would get through the Microsoft Graph JavaScript SDK. So the usage is exactly the same. Okay? So we're getting the group ID of this particular group that backs the team, and we're pulling its members, and that's how we know which users to render out into the card. Now, Daryl had mentioned about having the SDK split so that there's the core library and there are the richer types. Here I've actually pulled in that Microsoft Graph types library so that I can strongly type the responses that are coming back from the client as users. And then I'm separating those out into pilots, because the pilots are up at the top and the flight attendants are down at the bottom. And then passing those along to the next element in the chain, which are the crew member cards. So in the crew member cards, similar pattern and component did mount. Then we're going to make some additional graph calls. And again, this is where we see the concurrent calls happening, because as each one of these elements gets added to the page, they're all making their own individual calls for each user. We're making a call to get that badge data open extension, get that information. We're also making a call to get their photo. So these two calls, if you look closely, they're also concurrent. So there's two concurrent calls in each one of the cards, and then all of those are also concurrent. So it makes it nice, makes things load in as they come back. So I wanted to show you, since we have a little time, what those open extensions actually look like. So an open extension, as I mentioned before, is just a way for you to add extra data to a resource that already exists in Graph. And it's specific to your application. It takes any form, really. There's a few limitations on size and the number of open extensions that each app can add, but other than that, you can create simple, complex structures. It's all just basically JSON. So I'm logged in as Alex, and I'm going to cheat and use my history here so I don't have to rebuild that URL. But you can see I'm getting the me object, which is a user object, and then going a little further down the graph, I'm going into the extensions collection on that user, and then I'm asking for it by the actual extension name that we assigned when we created it. And if you look, and I apologize the size of the screen, but this is what the response looks like. So those status badges are just basically an array of strings. If they're there, they have the status. If they're not, obviously they don't. The progress badges have a little slightly more complex structure. So you have the name of the badge and their current count. And that's used to calculate if they're bronze, silver, gold.
Silver, gold. Yes. I think one of the really interesting things about that whole, we're seeing a whole set of fairly realistic business applications that people could build, and there's no back-end database, right? The data is in the graph, the security's already there, the data is stored in existing infrastructure that is available to you. It makes building these things a lot quicker when you don't have those back-end concerns of security and storage to worry about. So there's a few little things that I want to discuss around what we've seen and the idea of integrating experiences into existing Microsoft 365 products. In each of the different tools, there are different opportunities for integration. In Teams, obviously we have bots. And also, as we've seen in the demo, we have tabs. Bots are really good for user-initiated conversation and multi-step type of interaction where you want to be able to provide some information, collect some information. The tabs are good for visual displays, much like SharePoint also. And SharePoint is another great example. SharePoint is a great place if you want to create lists or documents and then be able to have links out to those documents and share those with other people. So the different surfaces have different values and fit into the ecosystem in different ways. Outlook has the notion of actionable messages, where you can use adaptive cards within actionable messages in order to present data and also get feedback directly within the context of where the user is. So you need to choose the surface that makes the most sense for the type of data that you are displaying. You've got to remember about, a bot is a user-initiated interaction where the user goes out looking for something. An actionable message is a server application-initiated thing. There are different scenarios that make sense for different use cases. And I want to touch on the notion of extensions, open types and open schemas, because there's actually two distinct ways of creating extensions within the graph. What Jason showed were open type extensions, which are simpler to start using, and the way you get at them is using a navigation property, an OData navigation property, of the entity that you are extending. And as Jason showed in Graph Explorer, you can create a fairly complex object to store all kinds of information in that extension, because you are limited into how many of those different extensions that you can create on a resource. But if you run out of size and you run out of capabilities, you can always put a link in there and point to another external system to be able to get at additional data. A client would then just have to take that link and actually dereference it to get the extra data. Open schema extensions are different in that you register the open schema extension. You say, there is this new type, and I want to introduce it to the graph. And it gets introduced globally to the graph. Anybody can then use that open extension once it's registered against a particular entity type. Now that extension actually appears within the object. You retrieve a user object, and if it has one of those extension values, that complex type will return back in the payload. And that allows you to do things like filter and select on those properties because it becomes a first-class property of the entity. There are limitations, obviously. You can only have 5 schema extensions per application, but there's a ton of value that you can have. And it's a trade-off. Maybe one will work better for you, maybe the other will work better for you. But it's good to know that both options exist. This is a classic software engineering decision, right? Buy versus build. Right? Should we build this stuff ourselves, or should we reuse some capability that somebody else has provided out of the box? We make that decision just a little bit easier because we don't charge you for any of this stuff. So it's like free versus build. So you can use the Graph Toolkit, you can use the SharePoint extension, use all MSAL libraries, the SDKs, and you can use them in multiple places. We've built these Delta queries to enable you to do syncing and change notifications and batch requests. Take advantage, don't reinvent the wheel, and hopefully you'll save some money in the process. Which brings us to the end of this story, and what our ask to you is to partner with us for productivity. Leverage the graph to be able to access your user data, to extend these models where needed to put your own data in. Understand our data access models to keep your data secure. Keep evaluating performance characteristics. What is possibly the first assumption is the right way of doing it, may not be. Measure, give us feedback. Use what you focus on delivering your business value and let us build a platform for you to build your applications on. And we have our own Microsoft Graph user voice now, so please provide us feedback. We're going through planning for our next semester. We want to know what is the most important thing to build. As I mentioned before, we are the first of the application sessions. It was the overview session yesterday. There are 3 sessions tomorrow, 8:30, 10, and 3:30. Please, if those applications are of interest for your type of area, please make sure you go there. We are easily accessible. Many of our PMs are on Twitter. All of our repos are in GitHub on Microsoft Graph. Stack Overflow, you have a question, there's a tag on Stack Overflow. You want to try something, you want to play around, join the developer program. You'll get a free tenant with 25 users that is renewable so that you can play to your heart's content and it costs you absolutely nothing. I have one final request. We love your feedback. Tell us what you thought of the session. Help us make the sessions better for next year. And with that, Jason and I thank you very much for attending.
Thank you.